I am now on page 10 of your class packets. So we've been talking about perpendicular and parallel lines. Now we're going to go into graphing absolute value equations. So absolute value are these bars. It means that that is the distance from 0. And Chapter 1, we practiced solving absolute value equations and solving absolute value inequality equations. Now we're going to graph both kinds. So we're going to start by graphing absolute value equations. And honestly, the easiest way to do it is to make an input and output table. If you remember what that is. So this is called the parent function, this y equals absolute value of x, because that's the simplest absolute value equation that you can graph. And to review how to use an input and output table is you come up with the values for x to plug in and see what you get out of it for y. These then become your points that you can plot on your graph. It doesn't matter what numbers you choose to plug in. I would choose to plug in small numbers because they're easier, but you want to make sure you have some negative and some positive in your input table just to give you a nice representation of the graph. So I'm just going to plug in -3 to +3. Those are going to be my x values that I'm going to plug into my equation for x. So if it starts off with the absolute value of -3, so that's what I'm first going to start by plugging in. Absolute value of -3, +3. So again, the distance that -3 is from 0 is 3. You can't go negative distance. So that means y would have to be 3 for that input value. So if I plug in -2, the absolute value of -2 is +2. Plugging in -1, the absolute value of -1 is +1. Plugging in 0, absolute value of 0 is still just 0. And then plugging in 1, the absolute value of 1 is 1. And, oops, I skipped 2. Plugging in 2, the absolute value of 2 is 2. And lastly, plugging in 3, absolute value of 3 is still just 3 because 3 is 3 spots away from 0. So, those all can be turned into points that you can graph over here. So my first point is -3, 3. So over -3, up 3. My second point is over -2, up 2. Next, we got over -1, up 1. My next point, 0, 0, that's at the origin. Next, 1, 1 would be over 1, up 1. Next point is over 2, up 2. And lastly, over 3, up 3. All absolute value equations should look like a V on your graph. Okay, the V could go up, it could go down, it could be shifted right and left, but it should look like a V every time. If it does not look like a V, you did something wrong. You plotted something wrong. So that is our first one. Now, if I do the second one, so I'm going to choose the numbers -3 through +3 again as my input values. So if I start by plugging -3 in for x, it would look like that. -3 plus 4 is 1. And the absolute value of 1 is 1. So there's my answer for the first one. So now, plugging in -2, -2 plus 4 is +2, and the absolute value of +2 is still just 2. Plugging in -1, -1 plus 4 is 3, absolute value of 3 is 3. Plugging in 0, 0 plus 4 is 4, absolute value of 4 is still just 4. Plugging in a 1, 1 plus 4 is 5, and then the absolute value of 5 is still 5. And lastly, 3 plus 4 is 7. Absolute value of that is 7. So there's the points I can graph. So my first one, -3, 1. So over -3 up 1. Next one, over -2 up 2. Then we got -1 up 3. 0 up 4. Okay, so it looks like over 1 up 5. It looks like I need some more negative numbers to plug in because it looks like my V is going to go like this. And I don't have any more points over here. So I'm going to go down here and add some negative numbers in. We're going to do -4, -5. So if I plug in -4, -4 plus 4 is 0. The absolute value of that is 0. So over -4 comma 0 is right here. -5 plus 4 is -1. The absolute value of -1 is +1. So over -5 up 1. So my V in this case looks something like this. Now, it's asking the question, what happened? What happened was, if you look at this first V-shaped graph we have, all we did was shift it to the left 4 times. And that has something to do with the fact that it says x plus 4. So we're going to talk about that more in the next examples, but there are some ways that you can kind of skip some of these steps to help you save some time when you're graphing absolute value. So if I come over here, so this next one, I'll show you how you can skip the input and output table. This time, the +4 is outside your absolute value signs. So if you have a number plus or minus outside your absolute value signs, that means you're going to shift, starting at the origin, your V either up or down. If there is a number plus or minus inside your absolute value signs, you're going to shift your V either right or left. Now, if it's inside your absolute value sign, you do the opposite. So since it says +4, I went to the left to -4. But if it's outside your absolute value signs, you don't change the sign, you just do what it says. It says +4. On the outside, that means I'm going to go up 1, 2, 3, 4. Now, as long as that number in front of your absolute value is a +1, which it is, that means every time you're just going to go over 1, up 1, and you can do that on both sides. You can then go back to your starting point, which is that +4, and go over 2, up 2 on both sides. You can go back to that starting point and go over 3, up 3 on both sides. And so forth. You could go over 4, up 4, over 5, up 5. It'll be that way every time, as long as the number in front of your absolute value sign is a 1. Now down here, you notice it's going to be a 3, so that little trick there isn't going to work. But when there's a plus or minus outside the absolute value sign, that means you're either going to go up or down with your starting point, or if it's on the inside of your absolute value sign, that means you're going to go right or left. Since it's +4, we went to the left to -4, and if you notice, you go over 1, up 1, over 2, up 2. You can do that on both sides. Over 3, up 3, over 4, up 4. It still followed that same pattern because the first number in front of the absolute value sign was a +1. Now, over here, we don't have any plus or minus inside the absolute value sign, as well as no plus or minuses outside the absolute value sign. And the first number is not a 1. So I'm going to start with the input and output table again. And start plugging those numbers in for x. So if I start with -3, it would look like this. The absolute value of -3 is 3, okay? So these absolute value bars go away, but I still have this 3 out in front. Now what do I do with those two numbers is you're going to multiply them together, because there is no plus or minus from the 3 to the absolute value sign. So that means it's connected through multiplication. So 3 times 3 is 9. That's my answer for the first one. So if I try -2 now, y equals 3, absolute value of -2. Absolute value of -2 is +2, so I'm going to bring that down as well as the 3 and multiply them together, which gives me 6. Now if I try -1, y equals 3 times the absolute value of -1, which is +1. 3 times 1 is 3, and so forth. So the next one, if I plug in 0 for x, the absolute value of 0 is 0, times 3 is still 0. Plugging in a 1, the absolute value of 1 is 1, times 3 is 3. Plugging in 2, the absolute value of 2 is still +2, times 3 is 6. Plugging in a 3, the absolute value of 3 is still 3, times 3 gives you +9. So there's the points on our graph that we can plot. I can't fit all those, like -3, 9, for example, I can't fit. So I'm going to jump down to -2, 6. So over -2 up 6, then over -1 up 3, 0, 0, over 1 up 3, over 2 up 6, and again, I can't fit that last point there. So there is my V-shaped graph. Now, there were some tricks you could have done with this one. So, for example, because there is no plus or minus inside the absolute value or on the outside of the absolute value, it means I'm going to start at the origin, 0, 0. And the first number was not 1, so I could not go over 1 up 1, and then over 2 up 2, and then over 3 up 3. That shortcut would not work. But if I times that outside number by 1, 2, and 3, it'll tell me what I have to move by. So for example, 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9. So that means if I start my origin, I'm going to go over 1 up 3 on both sides, which I did. I can go back to my origin or my starting point, go over 2 up 6 on both sides, which is what I did. Then you can go back to your origin, go over 3 up 9 on both sides, which I could not fit. So the table obviously works every time to give you actual points, but there are some shortcuts you can take to simplify this process.